Assalamualaikum warahmatullahi wabarakatuh. Good evening. Thank you for the chance that given to me to present on this day. First, let me introduce myself and my partner as my supervisor on this research. My name is Jonathan Yulianto with Mr. Bambang Sudarmanto and Mr. Ato Setiawan. Now, I would like to share about the numerical study of gas mixing effect on combustion stability in Block 3 and 4 Muara Towers gas turbine. We go to the first slide. Our agenda today is we are going to discuss about the background of this research, review study, research that we made, analyze, and the last about the conclusion of our research. The conclusion of combustion stability. The research background. First, that the gas turbine in Block 3-4 in Muara Tower operate 6 gas turbine simpen V94.2. Second, that gas turbine in Muara Tower act as a peaker system. We can see the load profile of the gas turbine. Every day start from 7 AM and then the shutdown around 8 PM. It happens every day like this. Number 3, that we have 3 different fuel gas supplier with its specific composition. The last thing is about the combustion stability issue on the gas turbine that affect on the reliability of our gas turbine. Then the previous study of this research is about what is the stability on combustion. What is the parameter of stability of the combustion? We try to research about the flame lift off and the blow off. Flame lift off described as a distance between the base of the lift flame and the burner mode as described as the lift off height. And the blow off is the condition of the flame that move away from the nozzle side and does not reach a point of stability until the flame extinguishes. Now, what is the correlation between lift off and blow off? Rayleigh and Garforth introduced an equation to correlate the lift off and blow off. Some equation provide here that the lift off height R, the lift off height is a correlation between the laminar burning velocity and velocity exit burner and the density. The research was conducted on a gas turbine combustor simpen type V94.2 at PLTG Muara Tower, Block 3-4. Number 2, the combustor to be analyzed is taken from one set of the silo combustion chamber with 8 combustor. Operating parameter of fuel flow rate and air flow rate using parameter during commissioning is approximately 137 megawatt. Then calculation validation by turbine inlet temperature. Next, the study was conducted to determine the level of stability, temperature, and NOx emission. Last thing, the variation of research with 3 gas composition and excess air varied from 5% to 15%. The method of our research is first that we are going to simulate these parameters, these 3 different fuel gas into some combustion chamber and 8 burner to get the result of the temperature distribution, stability, and everything. Before that, we have to do the validation. We use a operation parameter with one on 137 megawatt with this composition, with this all information to get valid data. First, we do the geometry and meshing. This is a simple geometry that we use to do the simulation. There is a fuel mesh flow inlet, air mesh flow inlet, and the outlet of the combustion chamber. For the data validation, first we do the geometry check to simulate fuel air and air inlet with a sphere flow toward chamber outlet. Then the convergent process. The convergent process we got on approximately 1,000 iteration. Then the grid independent. The grid independent. We do the mesh quality variation until relatively reach the similar value of the outlet temperature on combustion chamber. Then we get the value to the verification that we compare the both value, operation parameter, and simulation result. Each value given a differentiation from 0.5% to 5.9% higher. We go to analyze the stability from variation of fuel gas. This 3 picture is the temperature distribution of the high composition fuel gas, medium composition, and low composition. We can conclude that these temperature distribution so that the combustion with high composition will give a flame lift of around 0.18 meter. The lower gas composition will increase the distant flame lift of burner. The lower density will tend the burning velocity increase. How about the excess air addition? Excess air addition will also effect on the lift distance, a little effect on the lift of distance. The lift of distance relatively fixed around 0.2 meter. The addition of excess air causes the increasing lift of distance, and last, the addition of excess air will cause flame length getting shorter. The temperature distribution of the fuel variation, as we see on the graphic, that the higher composition, medium composition, and low composition will give different maximum temperature. The more methane content will give higher temperature content. Also, the maximum temperature of high composition of the fuel gas will be a little further than the low one, as we see the difference between the high composition and medium composition. There's a little gap on it. The addition of excess air, and effect to the temperature distribution, as you see that the use of excess air is to ensure the complete combustion. Then the maximum temperature, the maximum temperature position reach approximately 0.52 meter from burner. And too much excess air will lead to the lower outlet temperature. As we see from the graphic here, that more excess air will give higher temperature, maximum temperature, but then gradually it will decrease toward outlet combustion chamber. Now about the energy comparison. From the 3 fuel gas composition and for variation of excess air, we can say that from fuel composition indicate that the higher composition, the higher energy will produce. Then the addition of 15% excess air result optimal energy, although the temperature decrease happen on the chamber outlet. Then the excess air addition above 50% does not provide optimal energy because the temperature drop is quite high. The NOx emission, we go to the NOx emission. We compare the fuel gas combustion and the excess air addition. The temperature increasing will make higher NOx production, as we see from the graphic. Also, the lower of the fuel gas combustion will also tend the NOx production will be lower too. Then the addition of 5% excess air result the maximum NOx formation approximately 6.4 ppm around 0.52 meter distance. Our last presentation, we try to conclude our study first about lift-off and the methane content. The lower gas combustion will tend the higher flame lift-off with shorter flame length. The medium combustion increased by 10.8% compared to high combustion. But lift-off and excess air, the addition of excess air will cause the lift-off away from powder tip with shorter flame length. Then the blow-off, the lower gas combustion causes the blow-off velocity limit to decrease, and the addition of excess air also decrease the blow-off limit. The temperature, the lower gas combustion will give lower maximum temperature. Medium combustion temperature decrease 0.9% compared to high combustion. The excess air, that effect on the temperature, that the addition of excess air will give higher maximum temperature, but it will decrease gradually toward chamber outlet. The energy, the optimum energy based on outlet temperature is medium gas combustion with 15% excess air. Last NOx emission, the higher gas combustion will tend higher NOx production. The addition of excess air will decrease NOx production as a result of lower temperature. Well, thank you for your kind attention to join the presentation. Thank you. Assalamualaikum warahmatullahi wabarakatuh.